Thanks for meeting with us today. We're going to present our new quality assurance automation process that Tara is working on developing to ensure that we can eliminate other potential errors, flag other errors that come up in the account data moving forward. The QA software is going to consist of two parts. One will be the data verification, just verifying that the location and the accuracy of the data that we're pulling out of the files as recorded, the raw data from the counters, matches with what we're putting into the database for you. And then the validation step, take the actual data, compare it to historical data, other available things that we need to check that data against to make sure that the data matches what it should. And then within a certain allowable percentage. A little bit about the data verification. So module 1, we have pretty close to completed development. This basically goes and looks at, we're going to show you a demo of this in a moment, looks at the GIS file data, make sure that it's consistent with the reported data, looks at the date of the data collection, make sure that it was within a weekday, it was supposed to be not on Friday afternoon, Saturday, etc. We'll talk a little bit more about how that works. Module 2 is pulling the data out of the HCM database, putting it into Excel to remove that human error, retype everything to make sure that there aren't errors in the data entry process. And then module 3 is basically doing the same thing, but again, this would be with the mileage and base counts, pulling that data out of their spreadsheets and putting it into the database. The validation part of the process is more to look at what are the yearly variations. You know, if we can talk about a specific percentage, we would want to identify whether it be 5%, 10% for a specific area. We can put in these parameters and have it return flags in the data to show us where there seems to be anomalies in an automated process, so that it's not reliant on someone to go through the data and find it. It'll find it for us. It'll look at the directional variations of accounts. We can look at comparing the account variations. Historical data, we can also, if there's event data that you can find out where we know there's certain events going on, if you want to count those things, you can also flag. So now we're going to run through a quick demo of the process of how we've done things in the past versus how we're doing it now. So in the past, we've done a visual confirmation of the location to make sure that's correct. We've gone in, we've pulled up the location, we've gone in the data file that was there to look and make sure that matches what we received in the shape file versus what we got in the GPS coordination. So it was something where we had to do that manually. So now what we're looking at is having the system automatically just extract that GIS data from the counters, pull it in and compare it to the shape file data that's pulled out. This is a demonstration of how that exactly works. Assuming everything is good, it's not going to return any errors. We're just going to see that everything from the GPS data that we collected versus everything that we're supposed to collect matches. So we've run through this all. We look for errors. Pull up here. It'll tell us, there are 98 rows here. There are 98 rows in the spreadsheet. Looks like everything matches up the way that's supposed to do. 92 match locations here. But there were 6 locations that we need to go back and check manually that maybe did not work out where they're supposed to be for some reason. So we can go back to the Excel spreadsheet. Here we're doing a demonstration where we're going to put 3 things in there wrong. One, we're going to add 1 too many rows. Second, we're going to change. Third thing, we're going to change something to the weekend, but we also added a wrong address in there too. So we're going to intentionally put 3 years in there, save it, go rerun it, just to kind of show how the process works and trying to catch those errors automatically. So we know that we put them in there now. We're going to have the program rerun it. We're going to see if it finds those 3 particular errors. So going back to the data again, there are 98 rows, but there's 99 in the spreadsheet. So there's 1 extra. There's that verification. There's 1 extra row. Now there are 8 unmatched locations. And we need to go back and look at it. So that's basically how that works. Now we're going to quickly run through module 2 that we've developed. Again, this is just to take the data that comes out of the counter stage, the high-speed counters, and pull it into the database automatically. In the past, some of this has been done manually, or there's certain different things that can be introduced for error. So we're setting this up to automate the process. Here we're again introducing one intentional error into the data, and we're going to go back and show how the program picks out that there's something off about that particular count. And when we talked to MH Corbin, we've gotten some of the software parameter data that they use for classifications and that in the counters. So we've kind of pulled that into this as well, so that go through and analyze this data using some of the programming stuff from their counters, along with the data to make sure that what we're pulling out of the counter as far as classification speed, raw data, and transferring over is as it should be based on what's in their initial file. So it takes a little longer to run these, but again, this is a lot faster than having someone manually go through and do this, and it's less likely that there will be any human error introduced and translated the data from one program to another program. The automation of this, it's still going to flag things when they're wrong, but at least it kind of reduces the possibility for us to make an error or humans to make an error. Going through all this, we can see our rules, and there's 52 studies, there's 52 studies there. Some, here we only see there are 51 match studies instead of 52, so that's going to indicate to us that something's wrong. When we go back and try to locate that, then there'll be some effect of the count. So all of this is moving towards that idea of automating these processes so that we can find any errors that are in there. We can quickly locate where they are. We can find ways to look at them and find that data and address it as quickly as possible.